But I'm going to turn the microphone over to people who know what they're doing, uh, namely Peter Jones. There you go.
Thanks, Emily.
You're welcome.
Can everybody hear me? Yeah. I got a soft voice. In fact, my voice is a little hoarse today. But I think most of you know me. I grew up in Boyle, Mississippi, about 3 miles down the highway here from Cleveland. And presently I live in Anaheim, California. When Jill called me a couple of months ago about coming back to this, I really didn't know whether I was going to be able to make it, but I'm glad to be here today. And it's just a nice turnout to see everyone, and especially being away from this part of Texas for 60 years now. I left the Delta in 1959 when I graduated from Mississippi State in '59 in electrical engineering. I was there when some of you know Jimmy Chow was a graduate double E. He graduated a year before I did at State. Joseph Liu was another graduate engineer at Mississippi State at that time. He was a year ahead of me. He went to work for RCA and then ended up at Lockheed in Sunnyvale. I think Gil was there about 3 years behind me. I was a senior when he was a freshman, and I think about a half a dozen other guys. Thank you. About a half a dozen other guys were there that started with Gil, and Charles Everett Wing, I remember him, Star G, Roy Moon. In fact, I think I left all my lab reports with Roy Moon. And I think William may even have them today, right, William? No. You still on? Okay. Well, I don't know. Roy was telling me that somebody told him that he wouldn't have graduated engineering school without my lab reports. So, but I do remember working long hours on those reports. But it's nice to be back. And, I especially like to thank Jill and Emily and staff for putting this event on this weekend, and I think they deserve a round of applause for what they've done. But as you know, today we're celebrating the 50th anniversary of the Apollo 11 moon landing. And we're going to have a number of guests today to speak about their experiences on Apollo, and we're going to talk a little bit about science and technology, math and engineering. And so they're going to come up, and each of the speakers will talk a bit about their experiences on the program that they worked on. So I want to move forward to talk a bit about what I did working in the aerospace and defense industry. I started with North American Aviation in Los Angeles in 1959, working on some highly sophisticated aircraft at that particular time. The X-15 experimental aircraft was one of the first aircraft that flew into space. It brought back a lot of data that was used for the Apollo programs and the Mercury projects on the effects of space flight, especially on a human being. So I still remember actually when our test pilot, Scott Crossville at that time, crash landed the X-15 out of the Edwards Air Force Base. And he had to bring that plane in after it was launched from the belly of a B-17, because that plane actually had skis on it to land without wheels. And Edwards was a lake bed, so when he had an emergency and had to bring the plane in, he actually the skis on the aircraft actually folded up, and the underbelly of the fuselage cracked open. And sand poured all the way into the cockpit, and they literally had to dig it out. I saw the plane when they brought it back to the hangar the following week. So that was in 1959. But most of my work, though, was not on Apollo program, but although the company that I worked for, North American, built the Apollo spacecraft and also the space shuttle as well. North American was a pioneer company that was really an aircraft manufacturer at that time. And I got some pictures of some of the products that the company produced back during that period. Before I get to that, though, this is the agenda. The panelists that we're going to have today are going to be Josephine Jew, William Moon, Gilroy, and Martin Jew will be speaking later. So, and we'll have a question and answer period toward the end. This is the North American P-51 Mustang that actually flew during World War II for you military. For you military folks, you probably can remember this particular aircraft. It's a pretty popular aircraft during World War II. This is the F-86 Sabre jet that was produced by North American, and this plane flew during the Korean War. Okay? And it's quite an aircraft. When I was at North American in 1959, they were bringing a lot of these aircraft back into LA for maintenance and repair. And that was right at the Los Angeles Airport today where we're located in 59. I used to go out to fly night, watch these planes fly in. So. Again, this particular aircraft was a XB-70, and it was really a aircraft that was way beyond its time at that particular period. In 1960, when the Air Force was funding North American to produce a new bomber for the U.S. Air Force. But because of funding restriction cuts, that program was terminated a year after I was there. But I worked on the design of the caution and warning light panel for this particular aircraft. You can see it's a pretty good sized plane, but there was so much learned in the development of this aircraft that much of the technology that were produced at that particular time was used on the B-1 and B-2 bombers today that we have. Oh, I don't know if you've ever been to the Smithsonian in Washington, D.C. This is the X-15, the plane that I was talking about, and the one that Scott Crossdale flew, and he was actually competing against Chuck Yeager at that particular time. I don't know if you folks know about Chuck Yeager. But Chuck Yeager is a renowned test pilot who flew for the Air Force. He refused to join the astronaut corps because, he just said that he didn't want to be a monkey. But this plane is actually in the Smithsonian. And when I was back there a few years ago, I think the plane that actually cracked open, that's the one that's in the Smithsonian there. So they only built 3 of these at that time. William and a couple of the other folks here today. This is the Apollo Command and Service Module. They're going to be talking more about this particular project that they worked on. So, but North American got bought out by Rockwell International in the mid-70s, and they ended up winning the contract to produce the Apollo Command and Service project. So, also, Rockwell International produced the space shuttle as well. This was after the Apollo program was terminated. So, and, so actually, Rockwell is really a world-renowned aircraft and space company. Today. I'm not going to talk too much about Apollo, since the other guys are going to speak to that point, but my background was more in the missile defense sector. I worked on all the land-based ICBM projects for the U.S. Air Force, starting with the Minuteman I missile back in 1960. We built the Minuteman I, which was a single warhead ICBM. Then the Air Force said, we want a multiple warhead missile. So they funded a program called Minuteman II, and that was a missile that was able to carry 3 warheads, and it also had a lot of technology innovations in it, where we actually micro-miniaturized the components using integrated circuits. And before then, it was mainly transistors and diodes that we used on Minuteman I. And then from Minuteman II, we went to a system called Minuteman III, because the Air Force said, we want more capability now. And I'm talking about, this is the period of the Cold War. At that time, the superpowers were the Soviet Union and the United States. Both countries had nuclear capabilities at that time, with missile systems that could actually reach targets over 2,000 miles away. So there was a lot of competition going on back at that point in time. And then when we went to the Minuteman III, we actually produced a system with what we call post-loop propulsion capability, and it would carry 3 warheads. So one missile could actually knock out 3 targets in the Soviet Union. And from there, the Air Force said, we need more capability. So they funded a program called Peacekeeper. The Peacekeeper missile was another system that actually had 10 warheads on it, and could provide the capability to hit a target in the Soviet Union within a range of probably 20 feet, what we call a circular error probability. And that's the accuracy of that particular system. Within a football field, you could hit the target 3,000 miles away. But during the Reagan era, we signed a treaty with the Soviet Union to reduce the number of nuclear warheads in this country. Some of you might be familiar with that. It's called a SALT, Strategic Arms Limitation Treaty. And at that time, we had about 1,500 missile systems that were located throughout the United States. And because of the SALT, we went from 1,500 down to 500 missile systems. And that was still the Minuteman I 2 and 3, those systems that were started up back in those days. We still have the Minuteman today, and this is the only missile that is located in silos today across the northern parts of the United States. We have 500 of those, whereas years ago we had over 1,500. So, and because of all of that, and the Soviet Union was trying to stay up with us, their economy went downhill. And that's why the Soviet Union broke up. So, when a lot of my friends, we talk about funding for defense projects back in that period. You know, they were saying that, well, you know, was it worth the money spent? You know, but if we didn't do that, I don't think our country today would be as safe as it is. You know, so it did do a lot of good, as well as produced a lot of new technologies that we enjoy today. So, I don't think we would have these computers and laptops and iPhones, you know, and satellites that we have in space today that provide us all the information that we need to travel around this country. You know, so, but all that technology came from all the military projects and space program that we worked on back in that period of time. You know. Micro-mineralization, you know, was something that was not even known at that particular time. So, you know, Martin, like himself, was, you know, where he's building all this electronics today. You know, much of that technology came from this program back in that period of time. So, how many of you know, people know about Warner von Braun? Do you know who he is? Okay. There's a story about him. Do you know why his team ended up in Huntsville, Alabama? I did a lot of test work at the West End Missile Range and was at the museum there once, and they had a B-1, B-2 rocket that the Germans produced, and the story goes that von Braun and his team was doing some testing at the West End Missile Range back during that period of time after World War II, when they brought them over to the U.S. and they were doing missile tests out of White Sands. And this one particular test flight, one of the B-2s actually got out of control, and it flew off course, and it ended up hitting a cemetery in Mexico, which wasn't good, you know. You always say, well, you know, we've got to do something about that. So they actually moved Warner von Braun and his German staff to Huntsville, Alabama, and that's why they ended up over there instead of over the West End Missile Range today. So I thought that was kind of funny that, you know, they did that. So this Mexico, I guess, is so close to New Mexico. They couldn't actually control, you know, the precise targets that they were trying to hit at that particular time. So, I'm going to move on and introduce the next speaker, who is Josephine. Okay? She will talk about her experience on the Apollo program, so with Houston. So.
Thank you, Peter. My name is Josephine Jew from Houston, Texas. I was asked to speak about my life at NASA and also women in NASA. I was born in the back of a store in Vance, Mississippi, many years ago. So if you don't know where Vance is, it's like located between Marks and Dublin. At least it was there the last time I went by, about 20 years ago. When I was 3 months old, my parents made a wise decision in moving to Houston. The only other connection I have to Mississippi is my husband. Not my better half, but my other half, who is originally from here, Cleveland. Going back to Houston, I attended the University of Houston. I majored in math, and my minor was chemistry. And at the time I was graduating, I knew I didn't want to be a teacher or secretary. These were the jobs offered to most women at the time. But luckily, I took some courses at the University of Houston in Fortran and MAD, which was the machine language. Those were programming courses. And at this time, NASA was coming about. It was called the Manned Spacecraft Center before it became the Johnson Space Center. And Johnson Space Center was under construction at Clear Lake, which is just about 25 miles from downtown Houston. But there were like various buildings off-site that were being used until we made the big move to NASA out at Clear Lake. I was hired in NASA in 1963 as a mathematician. My title was changed to aerospace technologist, and the assignments required knowledge of various mathematical modules of scientific programming in machine and Fortran languages for the IBM 7094 computer. So if you go back in time, you remember that we had key punch cards, and you would use those as input to this large 7094 mainframe. And not only were you using key punch cards, but you would use like a mag tape, a magnetic tape, output data from the computer, and it would print another mag tape with data, or it would print to a large printer, large reams of paper. But since then, we've seen my career has experienced an evolution from punch cards and large mainframes, computers to remote, individual, desk and handheld processes. Moving up the ladder, 1974, I became the manager in developing the HAL compiler for the space shuttle. And you may have heard of HAL. It's not an acronym for anything, but you may have seen a movie called HAL, and some people thought of it as Houston Aerospace Language. But here's the document that we produced. And also a pamphlet, which we have here. But it was an avionics programming language. So we worked with Intermetrics, the contractor. They were located in Boston. Then, in 1984, I became the chief of the service center. It was responsible for the entire site in which we did the acquisition of PCs, IBM PCs. We installed them. The hardware, the software was what we call Word. And we did all the connections, the networking the maintenance. We had a help desk. If you have problems, you call the help desk. And we provided training. There was a computer facility where you could check out the software or the computer, take it home, and do whatever you need to do with it for like office work or just to learn about the computer and the software. Then, in 1988, 4 years before I retired, I became chief of MIS, Management Information Systems, for the newly formed Space Station office. I did pretty much everything that I was doing before, except we called them workstations, the PCs, and we did whatever we could, but it was restricted to the Space Station office. My manager at the time was William Shepard. He's known as Shep, and he became the first commander for the space station. So, just to make some comments about women in NASA. Out of the professional women at the time I was hired, I was the only Asian in the group of 8% professional women and 1 Hispanic. And I was the only Asian woman throughout my entire career where I was working. Now, I did hire an Asian young man at the time I was in charge of the service center, and he is still there. I touched base with him just recently, and he tells me that he plans to retire maybe 2 or 3 years. But in the group that we were in, there are about 100 people. 60% are men, 40% are women. There are 3 Asians there now, 2 men and only 1 woman. So, about the Civil Rights Act of 1964, it was created to provide the framework for achieving equal opportunity without regard to race, sex, and also for eliminating attitudes, customs, and habits which were denied women some occupations and high-level positions, and for encouraging women to compete in examinations and participate in training programs which lead to advancement. At this time, the Federal Women's Program was formed. I became a member. And the goal was to move women out of traditional jobs. The traditional jobs being clerical and secretarial positions. And at the time, there were like, at JSC, 4,000 people total, 4,000 workers total. And I understand that there were like 170 women were in professional positions. And at the time, we developed the Minority Profiles book here. This had all the, quite a few, I guess most of these folks, again, were minorities, but they were spread across all the NASA centers. And I was one of the 2 Asian women in this book. So, in closing, let me say, I think there is hope for the next generation of women. I look to the world that respects them for who they are. Be passionate and fearless. I want them to care about other women. We should lift each other up instead of bringing each other down. They should feel good about themselves, that they can conquer the world. Thank you.
Thank you, Josephine. I can really identify with you because I also was probably one of the first to hire a female woman engineer for my group when I was working for North American. I was in management too, and hired a female physicist graduated from St. Louis University. And she was probably one of the first female Asian engineer that worked at Rockwell. Yeah. So I want to congratulate you for your achievements. The next speaker is going to be William Moon. Before we get started, I'll just tell you the story about the jacket. Being this is the 50th anniversary of the Apollo 11 moon landing, there's been a big demand on the mission control operators around the world. And of course, with the advent of the movie Go Flight, that highlighted other people other than the astronauts, it highlighted the people in mission control. We also gave us a lot of notoriety. So for this jacket, I was invited to go over to Europe about 3 weeks ago, and in the contingent that went over there was Jerry Griffin. He was the center director of Johnson Space Center, plus he also was a flight director. And I also went with Dutch von Ehrenfried, and Cy Liebergott was one of the controllers on for Apollo 13. So I get an email from Jerry Griffin that says, hey, by the way, I'm wearing one of these things, you know. You might want to get one of these because, well, he being the center director got a bona fide flight crew jacket, and I had to go buy one at the store. But, so we went over to Europe, and it's a magnet over there because people in Europe really love the Apollo program. And we got a lot of comments as we walked through the airports. People would stop you and want to take pictures and ask for autographs. And I won't charge for autographs here, but in Leicester, England, we were invited with the Space Center UK, and we were celebrating Apollo 10. And we were doing fundraising for those guys, so they were charging 30 pounds for autographs, and another 20 or 30 pounds for photos, for each photo. So we did that for a couple of days, and then we went to Toulouse, France. And the French really milked us because we had interviews every day with every newspaper in town, every magazine in France, and then they brought all their relatives over to take pictures with us. So that's why we have this jacket. But back on the other theme, I want to mention that I mentored the now Deputy Center Director of the Johnson Space Center, is the first African American woman Deputy Center Director, Vanessa Ellaby. She started out working for me as a payload integration manager. I was a manager of the payload integration organization at Johnson Space Center for the shuttle program. But this thing working?
It should be.
This is a little presentation that I haven't looked at it for a while, but my granddaughter had me give this to the 5th graders at her school. And what they did was they had like 5 classes, and they brought them all into the library, and so I'll try to go through this thing. How do we use this thing? You know.
Yes, sir.
Where's the red lights? Oh, here we go. Everybody knows me as William Moon here. But when I worked at this Johnson Space Center, everybody knows me as Bill Moon. I'll go do this real quick. course, I'm from Boyle, Mississippi. I went to Mississippi State University. I saw Peter drive off to go to school in his little silver Chevrolet in 1960, right? Or 59?
59.
Yeah. And that gave me the impetus to become an engineer. So I graduated in 1964. And my first job was at McDonnell Aircraft, and everybody asked me what I did there. I was a design engineer on the Phantom II, and I dealt in construction, as I was telling. In '65, I went down to visit my brother Roy in Houston, and I happened to go by the Johnson Space Center, and I filled out one of these little innocuous forms, Form 71, I think it's called, and I sent it in, you know, and then thinking anything about it. But about a month later, I get a telegram under my door saying, hey, come down and work for us, and we'll make you a GS7. At that time, I think it was about $7,000. And I took a cut and pay. And I won't go through all this, but I ended up getting into flight operations director. Then it was called Flight Control Division. And I was hired on as a remote site systems engineer. And my first mission that I participated in was Gemini 8 as a trainee. And that was a flight that Dave Scott and Neil Armstrong was flying to perfect docking with the Gina. So they came over the tracking ship, and I'm sitting out in the middle of the Atlantic Ocean, and they docked, and as soon as they left us, everything was great. They came over to the next site, they were spinning 360 degrees a second. And they finally figured out they finally undocked and found out that, hey, it wasn't the Gina, it was a Gemini. And they got it back under control, but in doing so, they spent one of their RCS rings, and we had a mission rule they had to abort and see Japan. Well, lucky for them, they aborted, but we had to sit there and command the Gina. But before we could do that, they had to fly out a transport plane and parachute us a new tape to put in computers. We reloaded computers. We played around with the Gina. We ran out of food, and we had to fish off the side with some shrimp, and all we had was fish until we got into another port. And we ordered some meat, and they brought it outside of the lamb, I think it was. It's all covered with flies, but we ate it anyway. And from then, I worked all the Apollo missions. Started out with, we had the fire, and then we had a 2-year downtime. So the first flight we had was Apollo 7. That was great. But the next gutsiest call we made was to go to the moon on Apollo 8. And we had some Saturn V problems before then. And but we had an utmost confidence in command and service modules that Peter's company built. But that was a gutsy call to go to the moon. And then after we did that, we did Apollo 9. I think our daughter was born during Apollo 9. We learned how to use the limb at that time to maneuver the command and service module, which come into great importance on Apollo 13. Apollo 10, we went back to the moon and went down about 8 to 10 miles from the surface of the moon. We wouldn't let them land because the limb was too heavy. But we nearly lost the crew on Apollo 10 because getting ready to come back to the mothership at that time, I think it was CERN punching the commands to the abort guidance computer, and Stafford didn't know he did that, so he double commanded. They did the ascent to get back to command and service module, but they started tumbling. And luckily, Stafford got under control, and it was the first time that Gene Cernan made an X-rated expletive. He had to come back and get his priest to forgive him. But Apollo 11 was a great thing for the program. And we wouldn't have accomplished it without the teamwork that we had around the nation. It wasn't just the flight ops guys. We get a lot of the credit for that, but we had engineering, contractors, and it was a great achievement for it. But I want to highlight the other things that I did. Well, there's some pictures of Mission Control Center, and to prove that I was really there for Apollo 11, here I am, right here. That's the most iconic picture of the post-landing of Apollo 11. You'll find that in every magazine. But these are the programs we worked on, and at that time, we didn't have many Asians working there, and I was working back in the back room, staff support room. But on Apollo 14, 15, 16, 17, I made it to the front room that you see on TV all the time. And that's, when you make it to the front room, you're big stuff. Because you get to make decisions. But it wasn't all your own decision. You had people in the back room supporting you. Here again, we're showing Gemini vehicle that we did on Gemini 8. This is the thing we docked to. This is called the Agena. Of course, Peter has the same picture of the command and service module. Gilroy worked at the Grumman to make the limb for the lunar module landing. And then I worked on the Apollo Soyuz program in the front room as an ECOM. Was in charge of the ECOM position, in charge of the power and lighting for the vehicle, and also for all the life support systems, oxygen, hydrogen, but oxygen for the crew, in charge of the potty the crew used. We did the humidity control in there. We knew what other guys did because we controlled power to all their equipment. Now, I might want to mention something that us flight controllers walked around the center with a little bit of swagger. You get a lot of excitement during the dynamic phases during ascent and entry. Of course, when you initiate the entry burns, you're going to come in, but you had to have some quick recall on procedures. But the most dynamic phase is during the launch. You know, you're sitting there and you got to make a call, and you got to have the wherewithal to make a call to do an abort. In the econ position on Apollo 12, I was lucky that I got down there to do. I had an award, so I'm sitting there in the rain with Jimmy Stewart, the actor, and it launched, and we had lightning hit the vehicle, and it disconnected the fuel cells, and we're going uphill without any information. Luckily, the guy on the console that I usually work on was called the Econ console. He made a call to get us back telemetry to assess the vehicle, and we went ahead and made a very successful flight of Apollo 12. Matter of fact, once we reconnected the fuel cells back on the main buses electrically, that was probably the cleanest flight we ever had. And then, from the econ position on Apollo 13, it happened at the most opportune time where we had the explosion, and that the econ position was the one that was most effective because he had to make the call to get the crew into the limb as a lifeboat. And then we had to configure the vehicle to get it back safely. But to make the decision to go around the moon, and then of course we depended on, every time we went behind the moon and we had to fire the service propulsion system, there was a lot of tension there because we had the countdown clock when we really expected the vehicle to come around the backside of the moon. We knew we had a successful burn. And then we could also communicate with the crew. And on one of the flights, I remember the crew just bided the time and kept us in suspense for a long time before they answered us. So this is fun right here. On my shift, Deke Slayton decided to sleep in this portion of the docking module there. And of course, he sleeping in there, he hit a switch and dumped all the oxygen out of his bottles in there, and I had to go deal with that. On Apollo 16, one of my scary moments is on the first pass around the moon, the crew reported that it had a master caution warning on all the main bus underboats, and I said to myself, this is going to be my Apollo 13 moment, because that's the first thing you got when you had an explosion. But luckily, what happened on me was that the Murphy's Law came into effect. Every heater came on, but before I could assess the system, we were doing a pan-cam pass, taking pictures of the lunar surface, and I had to no-go that with the flight director and tell them I didn't want to do that. Just don't do it, we'll assess the system. Let's see. This thing right here.
I had more fun with this Skylab. On launch, we lost the heat shield and we lost one of the wings. It was supposed to look like this on orbit. We ended up looking like this. We had to do that. We had the first, we put the solar shield, if that's the second solar shield. The first one we made a parasol and popped it out of the scientific airlock. But on the next, on Skylab 2, we installed that, I call it a big sun shield, is what we call it. But this one we had more fun because I could help the crew out by sending commands. One night I'm on shift and cabin pressure started dropping. And I said, oh my God, we got a hole in the cabin. You know, that's the worst thing that could happen to an econ, a hole in the cabin. What are we going to do? Well, what happened was, it was getting close to the caution warning limit. We had set where I had to take some action. I was going to have to wake the crew up. They had gone to sleep. So I sent a command to pressurize the cabin. A little later, the crew woke up. He had to go to the potty. He says, hey, I hear something from behind this panel. What's going on? And I'm sitting there going, oh, telling him we're taking good care. And, you know, I sent a command and just replenish the oxygen and nitrogen. And then, now this flight, shuttle, Josephine worked, oh, I'm supposed to blame you for all the computer problems we had on site, right? This one, other than Apollo 8, this is probably the most gutsiest call ever. I'm on the launch team on this one. We had the solid rocket boosters we had tested out in the Promontory Point in Ogden, Utah. We fired the solid rocket boosters there. We fired the main engines down at Stennis to check out the big engines. We flew the shuttle off of a 747, but we never flew it together as an integrated system. We had avionics on both of them, everything. So I'm sitting there on launch day and I'm crossing my fingers, you know, hoping everything works fine. But it worked great. And I flew all four of those vehicles from the ECOM, and then after that, I got into management. The people that worked for me worked out in the front room. And I'm just showing you some pictures of all the flights we had. Of course, we had our accidents that took two of our vehicles, and we lost some good crew people. But back to Apollo 11, we would never made it if it wasn't for the teamwork that we developed at NASA. You know, the flight controllers walk around with a lot of swagger, and we get a lot of grief from them now because they don't get the accolades that the operation guys get. But if you really want to look at teamwork, this is where you're going to get it. And you think that, you know, those consoles you see there in the Mission Control Center, they were only display devices. You guys got more computer memory and capabilities in your cell phones than we ever had. On shuttle, we only had 256K. On Apollo, we had less. And the computers we had on board, you couldn't reprogram them because we used rope core. They hand wired them. And you could change a few constants, but nothing else. So, but back during the Apollo program, we did mostly, Peter says, slide rules, you know, adding machines, plotting on graph paper, and that happened all the way through the shuttle program from the standpoint of Apollo. But, you know, I was there for 37 years. I wouldn't trade it for anything else. NASA was a great environment to work in. And we made a lot of good friends, and we have a big reunion coming up here in July the 21st, and we're going to have a lot of astronauts and just having a good time.
Thanks, William. You guys really did a great job on all those flights. I commend you for all the work you guys did. I don't know if you you probably didn't know this, but when you talked about the Apollo 1 fire, you know, North American took the blame for that accident where we lost that whole crew. And at that time, I think some of our engineers told NASA that we should be doing that plug-in test on the ground in 100% oxygen. And that's what caused that fire, because of a frayed insulation wire in the cabin and 100% oxygen. Crew didn't have a chance. You know. It spread so fast that we lost the whole crew. Not only that, the door to the spacecraft was actually one that was designed to close inward rather than outward, so the crew didn't have a chance to get out. So that was another mistake. And NASA wanted that because Gus Grissom wanted the earlier flights. When he came back into the ocean, for some reason that door to the spacecraft blew open, and he almost drowned. We lost the capsule because the door opened outward. So they asked North America to redesign the door so it closed inward. So that was a mistake. But anyway, North America took the blame for that, and that's why NASA continued on with the program, because we were so worried about cancellation, and Congress would not continue to fund the money for those programs back then. So the next speaker is going to be Gilroy.
Thank you, Peter. This is a special time for me. I'm hearing these stories for the first time, just like you. As a freshman at State, as Peter mentioned, there's a fire in Old Main, and we were actually roommates for a semester, his senior year, my freshman year. And so I'm hearing these stories, and I'm hearing about the careers of people that I've known. I spent more time eating with them than talking about their professional lives. So I'm hearing things that it's exciting to know that these people have accomplished so much within their professional careers, and now we're all old folks retired enjoying our grandchildren.
I didn't set it up. You go ahead.
Yeah, like William, I spent more time talking about the Apollo days. I spent time with Grumman for a few years throughout the Apollo program, and then I went back into the missile business, building Sparrow missiles and phalanx gun systems for General Dynamics. But my actual career was building steel products in Clarksdale, Mississippi for over 30 years. So this is the...
Okay, you're clicking, I can't click.
Is it asking to click?
Yep, okay.
Now it's
If
ready.
you'll keep talking.
Yeah, okay, she's working on it. But I'm going to tell you a little bit about my family and Mississippi connection. So some of you out there will see your own picture, my family members. But
I'm sorry.
yeah, it's okay. I was born in Cleveland, a farm just 3.5 miles from here. And at a young age, we moved to New York, and I grew up in New York City. But I came back to Mississippi to go to school with my cousin at Mississippi State. And then John didn't go to Mississippi State. He ended up going to Del State, but I ended up with Charles Edward Wing from Marks at Mississippi State, and Martin was there at the same time. Of course, Bobby and Vic and others. George was at State together. So I finished in '65 and went back to New York. Went to work for Grumman and they asked me if I would go down to Florida and they provided an incentive. They would give us swamp pay. And so that was my incentive to go to Florida. But I didn't realize at the time that out of the thousands of people working at the Space Center, and in Brevard County, there were 4 Chinese. George G. and myself were roommates working at the Space Center, and the other 2 had the Chinese restaurant out of Melbourne. So those were the extent of the Chinese in Brevard County, Florida, down at the Kennedy Space Center. It was, of course, Cape Canaveral back in the day, and then became Kennedy. Okay. Before she gets there, so after the Space Center, I came back to Mississippi, and so my family were all born in Cleveland, and I'm the only one that came back. But I married Sally, whose family is here, and all 4 of her siblings stayed in Mississippi. So many of y'all have left Mississippi, but several have stayed doing things like Harry, pharmacist, pharmacy. There are some cousins that have been in the medical field, dentists. So not everybody is, and Martin, of course, will be speaking later, has his own company in Starkville. So there are still some Chinese in Mississippi, but not nearly as many as back in the 60s. There were about 2,500. As I said, I worked in Clarksdale, plant engineer, for 36 years. But everybody is interested in knowing about Apollo.
I got it.
Okay, which button?
Red lights on.
Your middle push button. I messed you up. I'm so sorry. Well, now this doesn't work.
Okay, I'll just keep pushing buttons and then there we go.
Somehow we got that.
Button.
It's gonna happen.
So there, Sally and I visiting down at one of the reunions. Plant I worked for was Metso, a Finnish company. Go ahead. Next. Nothing's happening. Roll up.
It's not changing.
Yes.
Red lights on.
Y'all are being great.
Point it over here.
Intolerant.
Point up here.
There you go.
Red lights on.
Is that doing it?
Yeah, now it is. Now not full screen.
Did it start?
Yeah, it's on, but it's.
Here we go.
No, next slide.
Here we go.
Yeah,
We're working out.
you're good. You're good.
Oh, this.
Okay. Thank you. Yeah,
Sorry,
yeah,
Mike,
yeah.
go for it.
Okay. So as I mentioned, Sally's been out of Mississippi twice. Once was to go down to the Space Center where she taught. There's a picture of her watching a softball game between the contractors and the astronauts. Contractors won, 18-14. Alan Shepard's a great astronaut, but not a good softball player. Gene Cernan is a great softball player. Harrison Schmidt at one of the reunions, and that was the school she taught at. As they say, this is our family. Some of us are here, but we're still in Clarksdale, Cleveland, and Marks. My family, that farmhouse I was born in, my dad settled in the 1920s, and my 6 siblings were all born in Mississippi. As a child, I never thought about going to the moon, but I would look at it and see, studying astronomy and scouts. But I was in school when Kennedy made the mandate. I had no thought of going to work or even NASA being an organization. You see on Williams' jacket the same logo. But how do you go to the moon? There's several different theories of how to go, and lunar orbit rendezvous was the chosen method. The hardware to do that, to fly to the moon and back. How far is it to the moon? Anybody know? 239,000 miles, man that knows. Mercury, send 1 man. Gemini, send 2 men. Grumman was the contractor that was chosen to build the lunar module. The only spacecraft made to operate only in space, not on Earth at all. But Grumman was building airplanes, a lot of Navy planes. Grumman on an airplane is like sterling on silver, was what the Admiral said. But what does it take to go to the moon? A Saturn V rocket with 5 huge engines developed at Stennis in Mississippi, but built by Rockwell. So we get lots of advertising, lots of contractors. Most people don't realize that NASA doesn't build anything, they contract everything out. So Rockwell, Boeing, McDonnell, IBM, RCA Communications, Honeywell, just so many people involved. And so the money that was spent on Apollo was spent all over the country. Launch control. Then the actual launch. I saw a piece that they could see that the Apollo 17 launch in Miami, 250 miles away. So one of the protocols is Florida takes care of everything until you get tower clear, and that's when Houston Mission Control takes off. When the bottom of the Saturn V clears the tower and you get the call tower clear, then Houston takes over and we get the next vehicle ready for processing. So Apollo 8, William mentioned the different details of the mission, the lunar module, the inside of the lunar module, very small space. Last time I heard Buzz Aldrin cussed out USOBs, put the hatch on the wrong side, the hinges on the wrong side. So it opened, so Armstrong was on the left, Aldrin was on the right, and that's how it was made. The cabin netting you see on the top was pulled out. So Aldrin is coming down. No, this had, most of the pictures you see of Apollo 11 are of Aldrin, because Armstrong had the only camera they had, the Hasselblad camera. So Apollo 13 got the figures of speech that we hear now all the time. Houston, we've got a problem, but Williams' boss, Gene Kranz, says failure is not an option. So 3 astronauts returned safely. 17 was the last mission to the moon, launched in December of '72. Cernan, Evans, and Harrison Schmitt, Jack Schmitt. So as we saw, after Apollo, you had the Apollo Soyuz, Skylab used some of the hardware from the Apollo missions that didn't fly to the moon. Space Shuttle, International Space Station. Larry is working that as we speak. He's taking a day off work. How are we doing it without you? No, but Larry's, William said 36 years?
37.
37 years. Larry's got 42 years with NASA, and he's still working. Josephine, how many years do you have, Josephine? 34 before
Larry
she.
used to work for me.
So we got to start. That's nepotism. Moon working for a moon. It's not what you know, it's who you know. No, but the International Space Station is still flying as you speak, and you have the little logo in your gift bags. 47 years later, you spend more time with the astronauts telling stories than you did when they were training. As William said, it's not the work. The work is exciting and it's fun, but it's about the relationships you have with people and the ones you meet and the ones you work with. So Fred Hayes have a piece of netting that came, that flew on Apollo 13. And so I asked Fred, I said, just what did you bring back? And he said, I just grabbed everything that was loose because I knew if we got back, we'd have to give the guys something. So he signed that piece of netting for me. It wasn't all work and no play. Softball with Cernan, Shepard, Joe Engel, other crew members. But we want to talk about the benefits of Apollo and STEM. There are so many benefits that have come about, and Peter has mentioned that things that come about in so many different areas, and Martin's going to talk about some of that. After we get through, everybody will come up here, and then we'll have time for question and answer afterwards. Peter will moderate that. What next? These are the next big plans, and we'll probably hear a little bit more about that later, about what NASA is doing now and what contractors are doing in the contracts. And the politics of the day will dictate how soon we get to the next mission. But I see a few young people out here, and why not our children and grandchildren? How do we get to Mars and STEM studies? I'd be remiss if I didn't mention we had some other people lined up. I mentioned Tony Sang. He went to Russia to learn to speak Russian to work the Apollo Soyuz. Kristen Kinder, her family came from Marks, Mississippi. She works for NASA as we speak, doing some of the space station work, and others. And there are other engineers out here that are in STEM-related fields, and so that's a good thing. So we'll have the question and answer later, but we want to talk about STEM and the technical aspects of things. And if anybody's in ham radio, you've probably come across MFJ Enterprise with Martin from Hollandale and Starkville. Just come on up.
Thank you, Gilmore.
It can, but it might jump out.
Is this about right? Okay.
It might jump out.
I have to hold it then. Wow. Wow, what amazing giants. These special Mississippi Delta Chinese are our very own. They stand with the very best that America has to offer. I'm so proud of their contributions. Can we please give them a big hand? I'm just a Delta Chinese nerd. I've always been an introverted nerd. Pocket protectors, thick glasses, nerd talk, that's me. Can you tell the difference between an introverted nerd and an extroverted nerd? When an introverted nerd is talking to you, he's looking down at his own shoes. But if it's an extroverted nerd, he's looking at your shoes. Well, what turned me into a nerd and gave me a lifelong career in my home state of Mississippi? The answer? STEM. S-T-E-M. STEM. What is STEM? Well, STEM stands for science, technology, engineering, mathematics. These subjects have traditionally been taught as separate, isolated courses. STEM education is an educational trend. It teaches children all of these subjects at the same time. Teaching these subjects as a unit removes the barrier between them, relates them to each other, and connects them to the real world. It makes this knowledge relevant, useful, and alive. It teaches by building projects and solving problems. It drives kids to work with each other and come up with their own ideas and inventions. They learn to ask questions, define problems, and find answers. They learn to analyze and interpret data and use mathematical thinking. They make arguments based on evidence. They see things differently. Their thinking is expanded. They develop discipline, critical thinking, and creativity, regardless of their interests or skills or career goals. I would like to give you a personal account of how STEM affected my life and how STEM led me to a lifelong career without leaving my home state of Mississippi. At a young age, I was always interested in all things technical. I read science books and magazines, built things, experimented in whatever was interesting. In grammar school, I was pretty much a lazy bum. In 6th grade, my teacher had a box full of math problems in an index card file. You could work them for extra points. I don't know what came over me, but I grabbed some cards and started working problems, and I found out I could work them. That was a turning point in my little 12-year-old life. From that point on, I strived to do well. As a Cub Scout, I built a World War II type of foxhole crystal radio. The crystal detector was a piece of pencil lead on an old rusty razor blade. Well, I never could get it to work. In high school, algebra, plane geometry, and trig were my favorite subjects. Physics and chemistry were taught alternately in the junior and senior year. I liked them because they explained many things that were happening around me. Our senior class plays was Oklahoma. I was cast as a square dancer. Can you imagine this Delta Chinese nerd square dancing? I couldn't. I quit the square dance group and volunteered to do the lights, the props, and whatever. And there was a scene with an overhanging fog, F-O-G, fog. Dry ice was usually used to produce a fog. But because of my new chemistry knowledge, I convinced my English teacher to let me use a cheap, easy mix of household saltpeter and sugar. And during rehearsal, I struck a match to the mixture. It made a perfect fog. It filled the entire 500-seat auditorium with dense white smoke that clung to the ceiling. Nobody could see anything. Nobody could breathe. Everyone had to evacuate right then and there. We went back to dry ice. In October of 1957, the Russians put Sputnik in the Earth orbit. I was fascinated and followed every word about the space program. I built a telemetry system out of junk radio parts. Humidity, light, heat, wind direction, and wind speed were transmitted and received by radio. This was a project to demonstrate how satellites worked. It won first place in the Mississippi Regional and State Science Fair. I passed the Federal Communications Commission radio exam and got my ham radio license in the 10th grade. I learned to copy Morse code by ear by listening to a home-built shortwave radio kit. And with my ham radio, I listened to the beeping radio transmissions of the Russian Sputnik satellites. I was fixing radios and record players and music amplifiers for the musicians that were playing the blues in the juke joints in Hollandale. And I was using these old used radio parts I took out of old radios that I got from our local radio TV repairman. I got a degree in electrical engineering from Mississippi State and a master's degree from Georgia Tech. Well, with the background in STEM and a brand new master's degree, what do I do next? Well, I did what any red-blooded Mississippi Delta Chinese would do. I went home and ran the family grocery store. My brother wanted to take off and travel for about 6 months, but that was where I got my MGS degree in business. MGS stands for Masters of Grocery Storing. When I was growing up, all I did was sweep the floors, put up the drinks, stock the shelves, and wait on customers. But when I had to run the store by myself, I learned how to sell, how to buy, how to work with people, how to stay in business, how to cut meat. And I remember the huge forequarters of beef. They were so big I couldn't pick them up. So I just dragged them across the floor. Cotton choppers would come in and buy lunch. They would ask for 15 cents worth of cheese and a packet of cracker and an RC Cola. Well, I couldn't always cut exactly 15 cents worth, and I would ask the customer, is 17 cents okay? And they would always say no. So I would just take a bite off the cheese and just wrap it up. I had a great time running the business, and I learned a lot, and I doubled the sales by the time my brother came back. When my brother came back, I spent a year working in Illinois and Indiana, designing military electronics for the Vietnam War. But one evening, while I was working in Illinois, I got a call from a professor at Mississippi State. He asked me if I wanted to come back and work on a PhD degree. He had some money for me. Well, I really didn't want to work on a PhD, but I did want to come back home to Mississippi, so I went back to Starkville. I finished all the PhD coursework in the first 3 semesters, and I was working full-time in the electronic engineering technology department. I was teaching and working on an underwater research vehicle. That was when I started MFJ. At first, I started an engineering design company. I was designing and building electronic circuits for research projects for the various departments at Mississippi State. MFJ are my initials. So I named my little company MFJ Enterprises because I didn't want to use my name just in case the company failed and ruined the family name. Well, after doing a few design projects, I figured out pretty quickly that all I could do was all I could do. I just couldn't get much bigger doing all the work by myself. I figured that if I designed some products and have other people build them, I could get much bigger, much faster. I had been a ham radio operator since I was in high school, so I naturally wanted to build ham radio products. And I decided to build a Morse code filter kit for $9.95 and a single sideband filter kit for $12.95 using the new high-tech operational amplifiers. Well, I placed the first MFJ ad in Ham Radio magazine, and it was a tiny 2-inch by 2-inch ad, and it was just full of technical engineering jargon. And if I read that ad today, I wouldn't even understand it. But I sold over 5,000 of those filters in a couple of years with those tiny ads. After the ad ran, orders started trickling into my personal student mailbox. I rented a broken down hotel room in downtown Starkville for $16 a month. That's 50 cents a day. It was a room that couldn't be rented to anyone else because the plumbing didn't work and there was no furniture and it was in pretty sad shape. I was doing everything by myself. Etching, drilling, stuffing, and soldering the PC boards, taking the orders, shipping the orders, writing the ads, everything. After a few months, the hotel manager ran me off. I was making too much racket and stinking up the place. When we started selling assembled, wired, and tested filters, I used to take these little bags of parts to my classes that I was teaching and asked if any of my students wanted to put these filters together for 25 cents a piece. Well, that was MFJ's first production line. I used to see our local telephone repairman working around Starkville. And I would stop him and I would ask if I could have this old scrap telephone wire that was in the back of his pickup truck. And that's what we used to wire up the filters. And to mount the printed circuit boards in the cabinets, we just glued them in. Well, after a while, I figured out what my fellow hams really wanted was a plug-and-play filter that was fully assembled and ready to use in a cabinet. So I bought these nice painted aluminum cabinets from Radio Shack. And it wasn't long until we bought all the little aluminum cabinet that Radio Shack had in the entire country. There were no more, and we couldn't get any more. So I found someone locally to cut up and bend up little aluminum sheets so we could make our own cabinets. I bought a spray paint machine from Sears and Roebuck. And we stood outside in front of our little 50-foot trailer wearing these old World War II gas masks. And we spray painted the aluminum cabinets. Pretty soon, all the cars parked around us started looking like the color of our cabinets. A major problem was how to put nice clean hose in the aluminum cabinets for the switches, the phone jacks, and the terminal strips. Well, I went to our local tool and die shop and had them build a punch and die set for making the hose. It was 2 half-inch thick steel plates separated about 1/10 of an inch, and it had a hole pattern for the switches and jacks. On the punch a hole, we slid in the metal cabinet, we dropped in the hardened punch, then we hit it hard with a hammer. And that punched out a nice clean hole. That filter cabinet had 11 holes, so we had to swing that hammer 11 times. I hired one of my students. His whole purpose in life was to swing that hammer all day long. That was MFJ's first punch press. Well, I didn't have a car that ran good enough to make it to the ham radio conventions. So I would invite students to go along who had a car. And sometimes I would go back to Holland and borrow my brother's car. You know, it's a wonder that I ever got married. My girlfriend taught ninth grade science, and before we were married, I borrowed her brand new car to pull a huge U-Haul trailer full of MFJ products to the Dayton Ham Convention. I burned out her transmission. She never let me borrow it again. After teaching classes on Thursday, I would drive all night to the Dayton Ham Convention. That way, I didn't have to pay for a hotel room. Then Friday, Saturday, and Sunday, I would set up, sail, break down, and then I would drive back all night Sunday just in time to give my 8 o'clock lecture the next morning. I spent the summer of 1974 with some students that I hired and designed, toured up, and got into production 7 more products. We placed our first full-page ad in QST magazine that September. Then 2 years later, we added an antenna tuner and a new tow-free telephone line and sold more in that November than in the entire previous year. We grew from 6 employees to over 30 in a few months, and I bought a no skating rink in Starkville and moved in. I finally quit teaching at Mississippi State when we had 30 employees. I never got around to doing the dissertation, so I never got the PhD degree. Well, that's how MFJ got started, and now, 47 years later, instead of 2 products, we now have over 2,000 ham radio products. Instead of a hammer, we now have computer-controlled punch presses for making the metal cabinets. Instead of handing a bag full of parts to students, we have automated PC board assembly that can place hundreds of surface mount parts in seconds. Instead of a tiny 2-inch by 2-inch ad, we're our ham radio's largest advertiser. Instead of a broken down hotel room, we have 4 factory buildings in Starkville. We manufacture more ham radio equipment than any other ham radio company in the world. 25% of our sales are exported to over 35 countries. That is the power of STEM, the space program, and the culture of growing up as a Mississippi Delta Chinese. Thank you.
Thanks, Martin. That was a great speech. I really enjoyed that. And I talked to Martin a while back, in fact, probably several months back when I went to a tailgate party at Starkville, and I remember some of my friends out on the West Coast had bought quite a bit of your product. In fact, my daughter-in-law's father's a ham radio operator. He came up to me once and said, "You know this Martin Jew from Starkville, Mississippi?" Well, I said, "I don't know Martin Jew, but he's probably a cousin of mine, being a Jew." And Jimmy Ling, everybody knows Jimmy Ling. He's a ham radio operator. And I think he visited your plant there a few years ago before he passed away. So I don't know, Martin. You did quite well for yourself, and I don't know if you would have done as well in the aerospace and the defense industry, though. But being a world-renowned ham radio business, that's really something. That's great. Okay, why don't we have everybody come up and maybe a quick question and answer period. I think we may have a few minutes for that.
Yeah.
Okay.
We're bringing some chairs up so everybody
What
can
if
sit.
all the speakers can come up here in case there's some questions. No, I do want to recognize others that are working in the aerospace and defense. business, even though no one asked to speak today. I'm sure there are others that are here today that have done that. So if you'd like to stand up and be recognized and give us your name and what you did, that'd be great. So I know George, George G, right? You work down at the Cape? Okay. And what was you, an auditor? You were the guy controlling the money then, right? Okay. Yeah, I think Bobby was also in that business.
I did the same thing like George did, but in Houston at the place for about 8 years, 67 to 75. I was the lead auditor at Lockheed Electronics and Silver War, who maintained the mission control theater security. So my brother William allowed me to sit next to him on the console for the last man in the movie. Apollo 17, December 15th. Let me sit next to him while he was I sat there about 4 o'clock in the night. This was the time when astronaut Survey was bringing the moving flying rovers. Somehow, Admiral Young was telling him how to fix it. He told him how to do it the old-fashioned American way. Take a couple of those laminate maps and put duct tape on it. So that was 1970. Fast forward to 1987. I get to go to Washington, D.C. on Tuesday. First thing I want to do is go to the American Smithsonian. Sure enough, on the second floor, it's off there. True story. All you gotta do is Google up Airspace Smithsonian, Rover, and
Thanks, Bobby. Hey, Larry? Hey, Larry, I got a few years on you. You're 42 years now, huh?
44.
Okay.
Still going.
I went 48.
Okay, 48.
Actually, I failed my first retirement. That's been 36 years. I did 12 years at the Boeing Company as a consultant, so yeah. You got a few years ago.
So I've been at the Johnson Smith since 1975. Was on the Mississippi State. My brother William was the one that kind of motivated me to follow in the footsteps of doing NASA. But also I have a double E degree as well. Started in 75 in engineering. I'm still in engineering 44 years later, but I have made other trips to like the Shuttle Program Office as well as the Space Station Program Office. But I began my career as a design development manager on electric power system on the shuttle. Crawled through every one of the shuttles that were ever built up at Palmdale.
Yeah, it's great.
For the distribution.
Palmdale.
So the wiring was all part of my system.
Mm-hmm.
STS-1 was very exciting, like William said. First time it had been flown by astronauts on board. Never been tested with a full integrated system. We were all nervous about how well the shuttle systems would survive. Right?
Right.
It was an exciting first mission, very successful.
Well, you guys did great. You know,
Huge.
I remember your mom very well, you know, so.
So many trips up to Palmdale during the build, manufacturing test of the space shuttles before they delivered to the Cape. One of my most exciting experiences while I was at Palmdale, actually outside, and SR-71 flew overhead. The fastest defense airplane the Air Force.
Yeah, I saw that plane up here, like the Air Force Base.
It was on its way back to Edwards Air Force Base, and I managed to see it fly overhead. Very exciting time.
You guys did well for yourself. Vic, I think Vic worked for Lockheed? Huh? You work for Lockheed?
Yeah, I work for Lockheed out at Johnson Space Center also. I was in the data reduction area with Lockheed. And I wrote a program to monitor all the lights
Okay.
inside the Mercury. When they turn it off,
Yeah, all you guys were operators, and I kind of worked more in the design area. And
And I was in Houston, when Martin came down to Houston and down to his research on underwater, he made a speech on it for the thousands of people. And I went over there, you remember that?
I remember.
Yeah. And he did not finish his dissertation on doctorate degree. And I told him, why don't you use that? But he never did. He would have got his doctorate out.
Any questions from anyone? Okay.
Name is Dewey Wong.
Dewey?
I'm not one of the Mississippi bred, from this area. I work for Lockheed Martin, and I retired from there. Scum work.
Scum work.
Operation.
Okay. Yeah. Thanks.
Hey, Peter, I want to ask, Obama's administration shut down the space program, but then Trump is going, President Trump wants to do this Space Force. What do you guys think about that?
Well, I think we're going to be going through an upcycle, I think,
I think it's
in
good.
science and technology right now. And that's great because I have a grandson that's graduating high school this year. He decided to go into aerospace engineering. And I told Nicholas, my grandson, I said, that's great. And maybe one of these days, I will be so proud of you, but you're working on the Mars lander, you know. I think that's going to be probably our next place to visit in space before maybe. We'll probably go back to the moon first.
He wants to
before
go
we
to Mars.
Mars.
I think he said Mars.
Yeah, Mars. Because I think that is one planet that probably will have humans that could maybe inhabit one of these days. So,
Anyone else on the panel have an answer for that one?
Well, I think we ought to go back to the moon first and learn how to live on another planet, but there's a lot of challenges to going to Mars.
sure.
I mean, radiation, how we grow our food, what we're going to do for the water. We get asked that question a lot when we go on these tours from all the Europeans, because they're working gangbusters on things like that too. But
I did a lot of nuclear test work on the programs that I worked on because the group that I had, that's what we were doing. We were doing nuclear radiation testing throughout the United States on trying to determine how do we design nuclear hardened electronic systems that would withstand a nuclear explosion in space. And we were spending so much money on reliability on the ICBM project. I remember Secretary of Defense McNamara asking that question back in 1975, whether a Minuteman missile could survive a nuclear explosion and still accomplish its mission. Nobody had an answer for him. So I and a few guys within North America, we got assigned to do some nuclear studies at that time. And we grew into about 270 engineers and scientists, and we peaked out and became a center of excellence actually for the company, where we did nuclear qualification testing for all our ICBM projects for the U.S. Air Force. But space radiation really is a real problem for long-term travel in space.
well, you know, I talked to some of the guys, and they're talking about maybe using water as a shield. It's going to, you know, right now, the hardened system is going to be your payload weight.
Water is a good shield for radiation. How do you live within that environment? That's the problem.
That's true. I might digress a little bit. That one of my exciting things on the shuttle program. One of the exciting things that I got to do on the shuttle program was I was in charge of all the runways around the world, but also, you know, in some jobs you have a little bit more pull. So I actually got to fly the 747 with the shuttle on the back. We took it up to, we flew out of Palmdale early one morning, and you're talking about, you know, when I was down there, I met Chuck Yeager and all the guys, and so we get out of Palmdale, and I got to go in the body of the 747. You look out the window, and you see the shuttle wings raised up like this and it really flex. And it was, we landed in Killeen, and the thing that made it so great was that the people in Fort Hood knew we were coming, and we landed there and we saw the whole base was surrounded by kids. They had come to see the shuttle land. But the other thing was when we landed, the soldiers, they were guards, young recruits carrying their weapons to guard the shuttle when we landed there. And likewise, when we finished up going to Fort Campbell, so that old schools out in Kentucky and Tennessee. And we had to do the tour. I had to go buy them another shirt. And about that time, we had a hurricane coming in at Homestead Air Force Base down in Florida, so they were shipping all planes up to Homestead. But everybody came to see it from those two states. That was an experience that I'll never forget.
Do we have any other questions?
Yeah, we've got about 5 minutes. We've got about 5 minutes.
We have about 5 minutes before we're supposed to be over in our planetarium. It is limited seating. If you, but so if there are, we have about 55 seats in the planetarium. So if you really want to be in the planetarium, you may want to head that way. If you would like to stay and visit, please feel free to do that.
Emily,
But give us about 5 more minutes.
can you tell us, the audience, a little bit more about the afternoon program? I understand we have somebody from Stennis.
We do, after lunch, where we'll have lunch here.
Use the mic.
Okay, I'll use the mic. So after lunch, we will be right back here. After the planetarium show, you'll have lunch. And then we'll have Deputy Director Galloway is here from Stennis, and he will give the program at 1:30. And then the program has just evaporated out of the top of my head. We'll be here. Oh, we will do Tai Chi. And we will have a discussion of roundtable discussion topics. And then we will go right back over to the CAPS building for a tour through the gallery and see what the kiddos have been doing. They're busy right now making science happen. Very cool. And then you have a little bit of free time and going to close out the day at the train museum at 5 o'clock downtown.